Welcome friends, welcome back to our channel Crystal Learning. So today we will take the subject manufacturing technology. The question which was asked, that was back geared head stock of a lathe is used for giving heavier depth of cut and feed. This is the very new point which I got to know about this back gear arrangement. Okay, because we know that back gear arrangement are used for speed reduction or spindle speed reduction and facilitating a wider range of speed. This question came in Maharashtra Public Service Commission assistant motor vehicle inspector. Okay, and that is mechanical engineering and automobile engineering. Okay, this is ME in 2017. So this question is very easy. That is effective reduction in spindle speed and facilitating a wider range of speed. But this giving heavier depth of cut is also the advantage of using back geared headstock. So let's see what is the arrangement. So we are giving rotatory motion to the spindle speed through the motor or some arrangement. So first arrangement is using only step cone pulley drive. Second is using with back gear drive, and third is using all gear drive without belt. Okay. So let's see what is back gear arrangement. So this is the complete diagram from where we will make clear all the concept about this back gear. So suppose this is the cone pulley. In the first, we are not using back gear arrangement. Okay, cone pulley means this type is the cone where some steps are created like this. So opposite type of part will be created where belt is there. This belt is in here. The motor is there. So this part will be rotating, and with help of belt, this other part of the cone will be rotated. Okay. So when there is no back gear, so we are getting, if there are four steps, 1, 2, 3, 4 only, so we will get four types of speed range. Okay, 4 RPM. Okay. And suppose we want more RPM range and a slower speed of the RPM. Okay, we want to decrease the RPM of the spindle to much lower level, then we have to use this back gear arrangement. For that we have to make some changes in this cone. So there is a shaft on which spindle is rotating. On this shaft, this S or spindle gear is fixed. Means it is welded with this, or this is a single part. Means this part is fixed with spindle. Okay, and this A, B, C, D, and this pinion gear is on this cone, rotating freely with on this spindle shaft, rotating freely. That's why it's shown with dash line. With why? Because it can rotate freely on this axis or on this shaft. Okay, so you got the arrangement that this spindle gear is fixed with spindle. Okay, so suppose we want only from that cone drive. Okay, so there will be a motion from motor, and we will have a belt that will rotate this, but as it is rotating freely, so it can't move the spindle. So we will fix this spindle gear with this cone part through a pin. Okay, when we just engage this pin, so the motion given to this cone will also transfer to this spindle gear, and it will rotate with the same speed as this cone. Okay, so here we will get 4 speed when this is engaged. But now we want to have further more speed ranges. So then what we will do, we will engage this back gear arrangement with this pinion gear. So now we will see with what is the motion transfer, and when you are engaging this back gear, you have to remove this pin. Okay, remove this pin. So when it is removing this pin, so it is getting free, means the this motion of the cone is free and this is independent. But what we are doing, whatever motion given to P, that motion has transferred to Q when you have engaged this back gear. So that motion has transferred to this Q, and the RPM of this Q is similar to R, and this R is giving now the motion to the spindle gear. Okay, so you just see the transfer of the motion. First belt is giving motion to this cone. Cone motion is the same as this RPM P. So P is transferring this motion to Q. Q has the same RPM of R, and R is transferring motion. So just see the circle. R is transferring the motion to the spindle gear. So now this spindle gear will be moving. What will be the RPM of this R, that will be converting into the ratio of the, depending upon the gear teeth. Okay, so that will be transfer the motion. So suppose if this gear or this belt is having on this B, so on this setting, like, we have two speed range. One is without one setting, one setting of this cone, one setting of cone, mean with or we say without back gear. and one setting is with back gear. So we see for every setting of this phone, we are getting two speed range, that is without back gear and with back gear. So if I have four steps, then total 8 RPM range we will get. Okay. So we have just seen we have increased the speed range also, and we are able to reduce the velocity or the RPM or the rotation of this movement, because this is the motion transfer from this pinion to this gear, and from this gear to this gear. This is larger gear and this is smaller gear, so that speed will be reduced. Okay, finally the spindle speed will be reduced. So we are able to justify two purposes, that is we are able to reduce the spindle speed, and second we are getting wider range of speed. So second part is over. Now let's read some few point on this. So thus we see two speeds are obtainable with each position of the belt on the pulley. If the pulley has four steps as illustrated in the figure, then we will have 8 spindle speeds. Thus this change by introduction of back gear not only reduces speed, okay, main function reduces, but at the same time it increases this turning power also. By reducing this speed, at the same time it increases turning power, and if turning power is increased, then it make it possible to take much deeper cuts on the work. Whatever the work piece, we will be able to take much deeper cuts. We will be able to increase the depth of cut. So just see, when slower turning speed or greater power than could be obtained from a direct drive is required, back gears are used. Means what are the function of back gear? If slower turning speed is required or greater power is required, then we have to use this back gear. And when the power is increased, and that we are able to increase this depth of cut on the workpiece, depth of cut and feed. Okay. So now let's go back to that question, and we see the options here. So now it's clear that why this option A is correct. Back gear headstock or lathe is used for giving heavier depth. When we want a heavier depth of cut and feed, then we have to use back gear arrangement. So I hope the explanation of this question is clear and some amount of knowledge has increased uh, with seeing this explanation. So it's better to solve more and more questions, because this concept was new to me, that how back gear is giving heavier depth of cut. Okay. So I hope you enjoyed the lecture of today. Meet you with the next lecture with a new concept. Till then, have a nice day.